All right, let's talk about one of the biggest, most exciting shifts happening in AI right now. We're moving away from AI that just talks to AI that actually does things. I mean, imagine giving your AI a to-do list and just watching it get to work. That's the future we're diving into today.
You know, for the past couple of years, we've all gotten pretty used to AI that can chat, right? It can write an email for you, summarize a long article, and that's amazing, don't get me wrong, but that's really just scratching the surface. The real question, the next big frontier, is this. What happens when we give that same intelligence the power to take action all on its own?
And look at this. This right here shows you just how huge of a leap we're talking about. I mean, not too long ago, if you wanted to build even a simple AI agent, you were looking at writing hundreds and hundreds of lines of really complex code. But now, we're talking less than 50 lines. For anyone who writes code, you know that is an absolute game changer.
Okay, so let's break this down. We are literally watching AI evolve right before our eyes. It's moving from being conversational to being autonomous, and that's a huge deal. We're not just talking about chatbots anymore. We're talking about intelligent agents that can run entire business processes or manage complex workflows.
And that brings us to the star of the show, the AI agent. This is the core concept that's making all of this possible. You can think of it like this. We're not just giving AI a mouth to talk. We're finally giving it hands to get things done. So, what exactly is an AI agent? Well, at its core, it's a piece of software that uses a big AI brain, a language model, to figure out what you want. But here's the kicker, the thing that makes it different. It doesn't just talk back, it acts. The two special ingredients are that it remembers your entire conversation and it can perform real tasks for you.
Okay, that might still sound a bit abstract. So let's make it super practical. Let's talk about something we all love to do, expense reports. Just imagine your company builds a little AI agent just to handle all that stuff.
So here's how it would go down. An employee just asks a simple question like, hey, can I claim my phone bill? Now the agent doesn't guess the answer, no. It goes and reads the actual corporate expense policy documents, so it gives you a correct, grounded answer. But then, and this is the magic part, it doesn't just stop there. It goes one step further and automatically submits the claim for you. See, it's connecting knowledge with real-world action.
Pretty cool, right? But that leads to the big question. How do you actually build one of these things? Well, that's where new toolkits come into play. We're going to look at one of them, Microsoft's Foundry Agent Service, which is basically designed to do exactly this.
So what is it? Think of it as a fully managed service. And what that really means is that it lets developers just focus on building the cool AI agent part. They don't have to worry about all the complicated, messy server stuff that runs in the background. The service takes care of all that heavy lifting for you.
Let's peek at some of the key features, because this is where the power is. First up, automatic tool calling. This is huge. It means the AI is smart enough to figure out by itself which tool it needs to use to get the job done. Then you have threads, which is just a fancy way of saying it remembers your conversation history, so it's not starting from scratch every single time. And of course, you get a bunch of ready-to-go tools, top-tier security, the whole shebang. All right, so how does an agent actually do all this stuff? What's going on inside? Let's pop the hood and take a look at the moving parts. It really boils down to three main pieces. First, you've got the model. That's the AI brain doing all the thinking and reasoning. Second, you need knowledge. This is all the information it can draw from, things like company documents or the entire internet. And third, and this is crucial, you have the tools. These are the functions that let the agent, well, do things. And it's that last one, the tools, where things get really, really interesting. This is where the magic happens. And it turns out agents have two different kinds of tools in their toolbox. You can think of it like this. You've got tools for knowing and tools for doing. The knowing tools are all about gathering information, searching the web, digging through files, that kind of thing. The doing tools are about taking action, running some code, booking a flight, you name it. And the smartest agents can look at a problem and figure out, okay, for this step, I need a knowing tool, and for the next step, I need a doing tool. It just switches between them seamlessly.
Okay, so we've seen the how, we've looked under the hood. Now let's pull back and look at the why. Why is this so important? What does this all unlock for us? Well, the possibilities are pretty much endless. Think about customer service. You could have agents handling refunds and answering questions around the clock. In sales, they could be qualifying leads and sending follow-up emails for you. For developers, imagine an AI partner that helps you spot bugs in your code. And on a personal level, we're talking about superpowered assistants that can manage our chaotic schedules and projects. And you know, what's really cool is that there isn't just one way to build these. It's not one size fits all. If you're a business user, you might use a simple no-code tool like Copilot Studio to automate a few daily tasks. But if you're a pro developer who needs to build something huge and super custom, well, that's when you'd reach for a heavy-duty tool like the Foundry Agent Service. It's all about having the right tool for the job.
I think this quote from Microsoft Learn just nails it. It says, agents go beyond traditional apps that just respond. The key words here are reason, act independently, and work together to get things done. We're moving away from passive tools that just sit there and wait for us to proactive partners that actively help us.
And that really brings us to the final, most exciting point. The technology to build AI that truly acts, it's not science fiction anymore. It's here, right now. So the real question is shifted. It's not, can we do it anymore? It's, what should we do with it? Now that you can build an AI that acts, what are you going to ask it to do?
All right, everyone. Let's talk about a tool that's completely changing the game for how developers build AI. We're not just talking about chatbots anymore. We're talking about smart agents that can run entire workflows for you. And we're going to see how you can now build all of it from one single place.
So let's just kick things off with a big what if, especially for all you developers and AI engineers watching. What if you could take the whole messy, complex process of building a secure, powerful, data-driven AI agent
And just pull all of that right into the one tool you probably already have open all day. I mean, no more juggling a dozen different apps and windows. That is the huge promise we are digging into today.
Okay, so let's get into it. To really appreciate why this new way is so good, we first have to understand the old way, the pain points developers face when they try to build these things from scratch.
You know, building a real AI agent that's actually useful is like running an obstacle course. You've got to deal with tough enterprise security, then you're trying to connect to these massive, sprawling data systems, and on top of all that, you're juggling a whole ecosystem of different tools. It's just fragmented, and it slows everything way down.
So, that's the mess. The question is, how do you clean it up? Well, let's look at the solution that promises to bring all those scattered pieces together into one development cockpit.
And here it is, Microsoft Foundry. It's an extension for Visual Studio Code, and you should really just think of it as mission control for the entire AI agent lifecycle. It's all about bringing Microsoft's powerful AI services right into the editor you already live in every day.
And this slide just lays it all out, doesn't it? The before and after. The old way was a headache, jumping between different apps to configure, test, and deploy. The new way with Foundry, it's all one integrated experience. You build it, you test it in a live playground, you tweak it, all from that one VS Code window.
Okay, let's get our hands dirty. How do you actually build one of these agents from scratch? This is where we get into the nitty-gritty of giving the agent its core identity and telling it what its job is.
Getting started is seriously almost too easy. Once you've got the extension installed, it's just a couple of clicks. You open the Foundry pane, you hit that little plus icon, and bam, you're looking right at the configuration screen. No complex setup, no command line magic.
And this is what you see first, the Agent Designer. It's this really clean visual interface where you start to define your agent's personality. You give it a name, you pick which AI model to use, and most importantly, you write the system instructions that tell it exactly how to behave.
Now here's the really clever part. As you're clicking around in that nice visual designer, the extension is generating and updating a YAML file for you in real time. This gives you the best of both worlds. A simple UI for making quick changes, and a code-first approach for when you need to do something more complex or check your work into source control.
And listen, this part right here is where the real magic happens. An agent is only as smart as its instructions. You have to give it a super clear role, a personality, and you absolutely have to set boundaries on what it shouldn't do. It's basically like writing a detailed character sheet for your AI.
An agent that can only talk is, well, it's just a chatbot. To make it truly useful, it needs to be able to do things. And that brings us to its most powerful feature, tools.
Think of tools as giving your agent arms and legs. They're basically just functions that allow the agent to reach outside of its own brain to perform actions in the real world, like hitting a database, running a piece of code, or connecting to an external API. This is what turns it into an automation powerhouse.
And the best part is, you don't have to build all this from scratch. Foundry comes with some really powerful tools right out of the box. For instance, the code interpreter lets your agent write and run Python code to do data analysis. And then there's file search, which lets it find answers by searching through your own private documents, which is a total game changer.
Okay, so we've designed our agent's brain, and we've given it some superpowers with tools. Now, how do we make sure it actually works the way we want it to before we set it loose in the real world? This is the key question every single developer asks after they build something new, right? You need a fast, reliable way to test and make changes because that's what a good development cycle is all about.
And the answer is the integrated playground. It's exactly what it sounds like, a chat window right inside VS Code, where you can have a real-time conversation with the agent you just built. You can check if it's following your instructions, see how it's using its tools, and test all the weird edge cases. This makes refining your agent incredibly fast.
So once you're happy with how your agent is behaving in the playground, the final step is, well, it's almost laughably simple. The entire deployment process is just one single button click in the Agent Designer. The extension takes care of everything else, pushing your configuration up to the managed service on Azure.
And this quote really just sums it all up perfectly. By bringing all these serious enterprise-grade capabilities into a familiar tool like VS Code, it's tearing down the barriers. It makes building these sophisticated AI agents accessible to way more developers.
So what we've seen here is that building powerful AI agents isn't some complex puzzle anymore that only specialized teams can solve. It's being brought right into the developer's command center. The real shift here isn't just about the tools themselves. It's about what becomes possible when every single developer can create and deploy their own custom automation. So that leaves us with a big question. Now that building an agent is part of your workflow, what are you going to automate first?
You know, we're living through this massive shift in what AI can do. For the longest time, we've had AI that knows stuff, right? It can write a poem, it can ace a history test. But the real game changer, the thing that's happening right now, is that we're building AI that can actually do stuff for us. We're moving from just knowledge to real, tangible action. And I'm sure you've felt this. You're talking to a chatbot that feels incredibly smart, but the second you ask it to do something super simple, like, hey, can you check on my order, or can you book a meeting for me? It just hits a wall. It can't. That little moment of frustration, that's not a bug. It's pointing directly at the big limitation AI has had for years, and it's the key to understanding what's next. So, what is going on here? Why the disconnect? Well, it all comes down to this fundamental gap in how most of these large language models work. There's this huge chasm between their, encyclopedia of world knowledge and their complete inability to take any specific, meaningful action in your world. And this right here is the perfect way to picture it. Think of it as the AI's blind spot. On one side, it's got the entire public internet, all of Wikipedia, everything. But on the other side, it's completely walled off from the data that actually runs your business or your life. Your company's private database, your inventory system, heck, even a simple weather app. That gap is what makes it feel so powerful, yet so useless for practical tasks. Okay, but what if we could just get rid of that blind spot? What if we could give our AI agents actual superpowers? Well, this is where things get really, really cool. And the way we do it is with a concept called custom tools. So, what on earth is a custom tool? Well, put simply, it's a piece of code that gives the AI a very specific skill. It's like a bridge that connects its big brain to an external system. And honestly, the best way to wrap your head around this is to imagine your AI agent is a brand new, brilliant employee you just hired. Okay, so right now, your new AI hire has a brain and can browse the public internet. Great, but it can't actually do any company work, right? A custom tool is like handing that employee a company phone and installing all the apps they need to do their job. One for the sales system, one for checking inventory, one for the internal calendar. Now it can actually start working. So, why go through the trouble of building these tools? Well, the payoff is just enormous. First off, you're automating all those repetitive tasks, which obviously boosts productivity. But you're also seriously improving accuracy, because you're pulling data directly from the source instead of relying on a human to get it right. And maybe most importantly, you can build solutions that are perfectly tailored to how your business actually runs. All right, so we've decided to give our AI a toolbox. But what kind of tools are we actually putting inside? Because it's not a one-size-fits-all kind of deal. There are a few different ways to build these skills, and each one is designed for a different kind of job. Let's break down the main options here. First, for really unique workflows where you need total control, you've got function calling. The analogy is perfect. It's like building a brand new custom app from scratch. Then, if your company already uses cloud software, you can connect your AI to it using Azure Functions. Think of that as logging into your company's existing programs. And finally, for public services, you use an open API. That's just like your AI using a public weather or maps app that's already out there.
Okay, the theory is interesting, but this is where it gets really powerful. How do all these tools translate into actual, useful superpowers for an AI in the real world? All of a sudden, the floodgates open. In customer support, an agent can now instantly look up your order and process a refund right there on the spot. For a retail business, it can check real-time stock levels and even start to predict when you'll need to reorder. In a hospital, it could securely pull up a patient's chart to schedule the correct follow-up. For an IT help desk, it could actually try to fix your problem instead of just creating a ticket. I mean, the possibilities are just about endless.
But here it is. This is the most mind-blowing part of this entire thing. It's not just that we can give the AI a list of tools. It's how the agent learns to use them, completely on its own.
Let's just walk through its thought process. A user asks, "What's the weather at the ski resort?" The agent understands the question, but it also recognizes, hey, I don't have live weather data. So it scans its toolbox, finds the custom weather tool, and here's the magic. The agent decides, all by itself, to use that tool. The tool goes and gets the data, hands it back, and the agent gives a perfect, accurate answer to the user.
Now this brings up a huge question, right? Does this mean developers have to map out some crazy, complex flowchart programming every single possible conversation to tell the AI exactly when to use each tool? You might think so, but the real answer is a complete game changer.
And there it is, the core idea. As the source material sets, you don't need to write code that explicitly calls your custom tool. The agent itself decides. Just let that sink in for a second. You don't program the when. You just give it the tools, and the AI figures out the rest. This is a fundamental shift in how we build software. We are moving away from the old way of doing things, where a human had to painstakingly draw out every single step in a giant flowchart. Instead, we're empowering the agent. We're just giving it a toolbox filled with powerful skills, and then trusting its intelligence to figure out which tool it needs for the job and when. So we've seen how these custom tools can turn an AI that just knows things into one that can actually do things in the real world. And that leaves us with one final thought to chew on. Now that an AI can be given pretty much any skill you can think of, what's the very first, tedious, time-consuming part of your day that you would hand over?
All right, let's jump right in. For the longest time, we've pictured AI as this one single super powerful brain trying to solve everything. But what if that's not the future? What if the real power isn't in one solo genius, but in a whole team of specialists working together? That's exactly what we're going to break down today, this huge shift from solo AIs to these collaborative multi-agent systems.
And really, it all boils down to this one question. I mean, you can build an incredibly smart AI, right? But even a genius hits a wall. So what actually happens when a task gets too big, too messy, or just too complex for one system to handle on its own?
Think about it like this. Picture an engineering team just getting buried in support tickets. You've got bug reports over here, brand new feature requests there, and server outage alerts popping up everywhere. Now imagine one person, or one AI, trying to sort through that chaos. It would get totally swamped, right? This is a perfect example of where that old single agent model just completely breaks down.
So let's really dig into the problem here. This first part, we're calling it one AI, too many jobs. This is all about the limits of that traditional do-it-all approach. Look, there's no doubt that a single monolithic agent can be powerful. But as you keep piling on more and more jobs, it just turns into this tangled mess. It's like a Swiss Army knife with 1,000 tools. Eventually, you can't even find the screwdriver. It gets hard to update, a nightmare to debug, and sooner or later, it just can't scale. It basically hits a complexity wall.
Okay, so what's the fix? That brings us to Section 2, Building the AI Dream Team. Yeah, you heard that right. This is where we stop thinking about a single, overworked employee and start acting like a manager, building out a team of absolute pros.
Now, the official tech term for this idea is connected agents. But all it really means is you take a massive, complicated task, you break it down into smaller, bite-sized pieces, and then you give each piece to a specialized AI.
They all then work together collaboratively to get the whole thing done. So yeah, what we're really doing here is trading that one do-it-all genius for a super efficient team of experts. Every single member of this team knows its job inside and out, and they trust everyone else to handle their part of the puzzle.
Of course, every great team needs some structure, right? So in Section 3, we're going to look at the two key roles that make these systems tick, the manager and the specialists.
Let's actually put their job descriptions right next to each other so you can see the difference. On one side, we've got the main agent. We're just going to call it the manager. And on the other side, we have the connected agents, which are our specialists.
And this right here makes the whole division of labor crystal clear. The manager, well, it's not actually doing the grunt work. Its job is to look at the request, figure out the goal, and then delegate the subtasks to the best specialist for the job. Then it pulls all their work back together into a final product. The specialists, though, they are totally hyper-focused. They do one thing, they do it incredibly well, and then they report back to the manager. Simple as that.
Yeah, you can really think of the manager as the ultimate project lead. Its most important skill isn't writing code or analyzing data. It's having that strategic vision, understanding the big picture and knowing exactly who to pass the ball to. It's the brain of the whole operation, making sure all the different parts are humming along together perfectly.
And the specialists, on the other hand, they're the experts on the ground. Each one is built with a single laser-focused job in mind. Maybe one is a genius at summarizing long, dense documents. Another might be an absolute wizard at pulling very specific data from a messy database. And that single responsibility design, that's the key. It's what makes the whole system so much more reliable and, believe me, way easier to maintain and upgrade down the line.
Okay, so we've met the team. Now, in Section 4, let's see how they actually put it all together and get the work done. We're going to walk through the whole workflow from the moment a request comes in to the final result.
The whole process, you can actually break it down into this really simple 4-step loop. And what's cool is that it feels less like some super complex algorithm and more like a standard workflow you'd see in any office. That's part of its beauty.
So here's how it plays out. Step 1. A new request comes in from a user. The manager agent grabs it. Then, step 2, it breaks down the problem and starts delegating the pieces to the right specialists. In step 3, each specialist gets to work, does its thing, and sends its results back. And finally, step 4, the manager collects all those individual reports, stitches them together into one coherent answer, and presents that final report back to the user. Done.
Now this quote, this right here is the secret sauce. The manager isn't running on some clunky, hard-coded, if this, then that logic. Nope, it's using natural language understanding to figure out who gets which task. And this is a huge deal, because it makes the whole system incredibly flexible. You can add a totally new specialist to the team, and you don't have to go back and rewrite the manager's entire brain.
And all of this leads us to our final section. The future is collaborative AI. So why is this team-based approach such a massive step forward? Let's get into it.
All right, let's look at the tail of the tape here. Compared to a single agent, this AI team approach is way more flexible. You can just pop in new specialists whenever you need them. It's more reliable, because if one little specialist has an issue, it's isolated and way easier to fix. But most importantly, it is built to scale. The system can grow gracefully, kind of like a well-run company adding new departments.
So, when you boil it all down, the benefits are pretty clear. You get a system that's easier to debug, and you don't need to build some crazy custom orchestration logic from scratch. You can create these modular specialists and then reuse them in different projects. And at the end of the day, you have a flexible system that's designed to grow with you. Now look, this isn't a magic bullet, right? Managing all that communication between agents can create its own headaches, and making sure the specialists don't contradict each other, that's a real engineering challenge. But the trade-off is you get a foundation that is just fundamentally more scalable and resilient.
This quote from Microsoft's own documentation really just sums it all up perfectly. The whole goal is to build a flexible foundation. You're not just building a one-off AI application, you're creating an entire ecosystem that can adapt and evolve as your needs change.
So, if there's one thing you take away from all this, let it be this. The future of building really complex AI, it's not about creating one single, all-knowing brain. It's about learning how to assemble, manage, and orchestrate a team of highly specialized experts.
And that leaves us with one last, pretty exciting question. Now that we have a blueprint for building these really sophisticated AI teams, what are the truly massive, complex challenges we should finally point them at? It seems like the only limit now is what we decide to ask them to do next.
Okay, so we all know AI agents are getting insanely smart. But how do they actually break out of their digital world to do stuff? For them to be really useful, they need to connect with outside tools. And believe me, that's a bigger challenge than you might think. So let's dive into the really elegant solution that's changing the whole game. And that brings us right to the heart of the matter. You've got this brilliant AI agent living inside a model. How does it connect to things we use every day, like APIs or databases or other services? How does it actually break out of that digital box and get things done?
Well, traditionally, AI agents have been stuck in what you could call a walled garden. Connecting them to the outside world? It's been a massive headache for developers, a totally manual, super complicated process for every single tool you want the agent to use. So on the left, you see the old way. It's all hard-coded. Just imagine a developer painstakingly wiring every single tool directly into the agent's code. If one of those tools gets an update, the whole system could just break. It's slow, it's fragile, but the new way over on the right is all about being dynamic. It's flexible, it's scalable, and it just works. And honestly, this analogy just nails it. The old way of giving an agent a new skill is like, imagine wanting to install a new app, but instead of just tapping download, you had to completely rebuild your smartphone from scratch. It's absurd, right? It just doesn't make any sense.
So, how do we fix this mess? Well, the solution is a beautifully simple universal protocol. It is time to introduce the hero of today's explainer, the Model Context Protocol, or MCP for short. So what is MCP? At its core, it's a standard. Think of it like a universal language or maybe even a universal plug that fits any outlet. It creates a standardized way for an AI agent to automatically figure out what tools are out there and how to use them, without a developer having to write a single line of custom code for each one. Okay, so how does this actually work in practice? Well, MCP has two key parts, a server and a client. And sticking with our phone analogy, you can think of this whole system as being like an app store, but for AIs. Let's see how those pieces fit together. The MCP server is the app store itself. It's a live catalog, basically, that holds all the tools, all the apps that your agent could ever want to use. The MCP client, on the other hand, well, that's the installer. It's the bridge that connects to the App Store, sees what's on the shelves, and gets those tools ready for the agent to use. All right, let's walk through this step by step. First, you ask the agent a question. The agent thinks for a second and realizes, hey, I need a special tool to answer this. So the MCP client pings the MCP server and basically asks, hey, what tools you got? The server shoots back a list. The client then grabs the right tool, registers it with the agent, and boom, the agent can now use that tool to get you an answer. Simple as that. And right here, this is where the real magic happens. This whole process is called dynamic discovery. And I want you to notice what didn't happen in that workflow. A developer didn't have to write any new code. They didn't have to restart or redeploy the agent. The agent literally learned a new skill on the fly. The original source material calls this an integrates once approach, and that phrase just captures the benefit perfectly. You set up this connection to the MCP server one time, and from that moment on, you can add new tools, update old ones, or even remove them on that server without ever having to touch the agent's code again. It cuts down on maintenance like you wouldn't believe. So this dynamic approach, it brings a ton of advantages to the table. It's scalable because adding new tools is a piece of cake. It's modular because the agent gets to stay simple and focus on its real job, instead of getting bogged down with managing tools. And here's one that developers will absolutely love. It's interoperable. That means you can swap out the underlying large language model without having to rebuild all your tool integrations from scratch. That's huge. So what's the big picture here? What's the real payoff? Why should we all care about this? Well, it's all about building an AI that is genuinely future-proof, one that can grow and adapt without constant, painful manual work. This table really just sums it all up. We are moving away from a system that's manual, rigid, and brittle, and into a new world that's automatic, flexible, and adaptable. Tool updates go from being a major project requiring a full redeployment to just a simple, centralized change on a server. All that complexity gets moved away from the agent itself. When you get right down to it, MCP creates this clean separation between the agent's brain, its logic, and its hands, the tools it uses. And that creates an AI that isn't frozen in time. It builds a foundation that can grow and learn new skills just as fast as we can dream up new tools for it. And that leaves us with a really exciting thought to chew on. For you and me, this means the AI apps we use could get smarter and more capable literally overnight, without us even having to click update. An agent could learn to tap into a new company API, or a new data source, or some new service, all in an instant. So the question isn't just about writing better code. It's about what really becomes possible when an AI's skills can grow and evolve every single day.
All right, let's dive in. If you are getting ready for that AI-102 exam, you absolutely know that AI agents are a massive topic. So today, we're going to break down exactly what they are, and more importantly, how you can really master them, not just to pass the test, but for building some seriously powerful apps.
I mean, really think about that for a second. Most of the software we use is, well, kind of dumb. It just follows a script. But what if an application could actually understand a complex goal you give it, figure out all the steps on its own, and then just do it? No handholding required. Well, the cool thing is, that's not science fiction anymore. That is exactly the power of AI agents. And over the next few minutes, we're going to see precisely how they pull it off, especially using the Microsoft Agent Framework. So first things first, what really makes an AI agent different from just a regular computer program? You know, it all boils down to one critical word: autonomy. See, that word right there, autonomously, that's the key. An agent isn't just a simple tool, like a hammer that you have to swing. It's much more like a super-powered assistant. You don't tell your assistant how to draft an email click by click. You just give them the goal. The agent, which is powered by generative AI, figures out all the rest. Here's the best way to picture it. A traditional program, it's like a train on a fixed track. It can only go where the track is laid out, and if something's in the way, it just stops. But an AI agent, that's like an all-terrain vehicle. It can find new paths, drive around unexpected obstacles, and still figure out how to get to the destination. Okay, so we get what they are conceptually, but how do we actually build them on Azure? Well, that's where the Microsoft Agent Framework comes into play. You can think of it as the ultimate construction kit for creating these intelligent assistants. This framework is going to be your best friend. It's an open-source SDK, which is just a fancy way of saying it's a pre-packaged set of code and tools that does all the heavy lifting for you. It handles connecting to the big AI models and provides the whole foundation, so you can focus on what makes your agent special, not on writing the same boring setup code over and over again. All right, everybody, listen up, because this is a big one for the AI-102 exam. While the framework is flexible, whenever you see questions about enterprise-grade stuff, top-notch security, massive scale, deep integration with other Azure services, the answer they're looking for is the Microsoft Foundry Agent. It's the supercharged, business-ready version. So let's quickly peek inside this toolkit. You've got the agents themselves, which are the main brain. Chat providers are how you connect to models like Azure OpenAI. Function tools, these are the agent's superpowers, and we'll talk a lot more about them in a second. And then you have systems for conversation management, so the agent remembers what you talked about, and workflow orchestration for when you have multiple agents working together.
Quick pause for a second. If this video is helping you understand AI and Azure concepts more clearly, take just 1 second to hit the like button, so YouTube knows this content is useful. And if you're interested in learning more about AI, Azure, and real-world AI development, consider subscribing to the channel. I regularly post practical tutorials, hands-on labs, and certification guides just like this. Also, I'm curious, what AI topic are you currently learning or struggling with? Drop it in the comments below, and I might create a future video around it. Your support really motivates me to keep producing free educational content for the AI community. Thanks again for watching.
Now for my favorite part. If the large language model is the agent's brain, then tools are its hands. This is how an agent stops just thinking about things and actually starts doing things. And I can't stress this enough, this is the most important concept to grasp. Without tools, all you have is a really smart chatbot. But when you add tools, you get a true agent. Tools are what let the agent break out of its digital box and actually interact with the real world, to search the web, to pull data from a database, even to send an email. It's a complete game changer. The great news is that the Microsoft Foundry agents come with some incredible tools right out of the box. I mean, without you doing anything, your agent can already run Python code with the code interpreter, dig through documents using file search, and browse the internet with web search. That's a ton of power right from the start. But this is where the real magic happens. Those built-in tools are fantastic, but the true power is in the framework's flexibility. Let's say you need your agent to talk to your company's internal sales system or a custom database. No problem. You can just build a custom tool for it. And creating a custom tool is surprisingly easy. First, you just write a regular old Python function. Then, and this is the key part, you add a special little line right above it called a decorator, at tool. Think of this as a neon sign you're putting on your code that tells the agent framework, hey, this function right here, it's a special skill my agent can use. Finally, you just register that tool with the agent, and that's it.
All right, so we've covered the what. Let's switch gears and get into the how. What are the actual code components you absolutely need to know to build one of these agents, especially for the exam?
Okay, another major exam alert. You're going to want to remember these names. The Azure OpenAI Responses client is basically your pipeline to the Azure AI service. The agent class is the main object. It's where you define your agent and its personality. The agent session is super important. It's what manages the conversation history, so the agent has context. And, of course, tools integration is just the process of giving your agent all those cool superpowers we just talked about. You know, theory is great, but let's see how all of these pieces actually click together in a practical, everyday example. We're going to imagine an agent designed to process expense reports. So here's the setup. An employee has a file with all their recent expenses. They need our agent to read that file, create a quick summary, and then email it to their manager. This is a perfect task for an autonomous agent. Now, look at how the user asks. They're not giving a list of step-by-step commands. They are just stating their goal in plain, normal language. They're saying what they want, not how the agent should do it. So what's happening behind the scenes? Well, the large language model is smart enough to understand the user's intent. It picks up on keywords like summarize and email. And because we built a custom tool called Send Email and gave it a good description, the agent intelligently figures out, aha, this is the right tool for this job, and activates it. And there it is, the result. The agent successfully used the tool, which would connect to a real email service, and it got the job done. It took a simple, abstract request and produced a tangible, real-world action. And if there's one thing you take away from this whole explainer, it's this simple equation. The large language model provides the understanding, but it's the tools that provide the ability to act. That combination is what makes a true, autonomous AI agent. Okay, let's lock in the key takeaways for your AI-102 prep. First, agents need tools to take real-world actions. Second, for big, serious business apps, you're going to use Foundry agents. Third, to create new skills for your agent, you use that magic @tool decorator. And finally, to remember the conversation, the framework uses the agent session class. Got it? We've covered a lot today, but now you have the blueprint. You understand the core pieces and the incredible power of giving AI the ability to not just think, but to do. So the only question left is, what will you build? What tedious, complex problem are you going to automate with your very first agent? Thanks for tuning in. Hey everyone, and welcome to The Explainer. Today, we're diving into Azure's playbook for building really powerful AI teams. Now, if you're studying for the AI-102 certification, this is a big deal. Mastering multi-agent systems is absolutely crucial, and we're going to cover exactly what you need to know. You know, we usually think of AI as this one, single, super powerful brain. But honestly, some challenges are just so complex, so multifaceted, that they need a whole team of specialists all working together. So the real question is, how do you build and manage that team? Well, let's find out. So here's our game plan. First, we'll talk about why you'd even need more than one agent. Then we'll get into Microsoft's agent framework. That's basically the rulebook for building your team. And finally, we'll walk through the 5 core strategies or plays you can use to get your AI agents to collaborate like a well-oiled machine. Okay, so when does a solo AI genius actually need some backup? Let's make this real with an example that shows you exactly where a single agent just can't keep up. Just imagine you're managing a big, complex application. An AI trying to monitor the app, figure out the root cause of a problem, deploy a fix, and then report on it all at the same time? No way. It would be totally overwhelmed. This is exactly where a team of specialized agents isn't just nice to have, it's essential. So instead of one agent trying to juggle everything and probably dropping the ball, you build a dedicated team. You have a monitoring agent, a root cause analysis agent, a deployment agent, and a reporting agent. They work together, coordinated, and they streamline the entire process. That collaboration, that's the secret sauce of a multi-agent solution. All right, so you need a team, but to build these AI teams right, you need a solid foundation, and that's exactly what Microsoft's agent framework gives you. Now, this is super interesting because this slide gives you the fundamental building blocks. Just think of it like this. The agents are your players on the field. The agent orchestration is your game day strategy. And the tools? That's their special equipment that lets them do things in the real world, like run code or search the web. So you've got your star players, but how do you get them to actually work together as a team? How do you make them a cohesive unit? Well, the answer is a big one: orchestration. A workflow is basically the game plan. And listen, for anyone studying for the AI-102, put a giant star next to this word, orchestration. It is all about designing and managing these collaborative workflows. It's a huge concept. And this slide is brilliant because it shows you how those workflows are actually controlled. Think of edges as the communication lines that connect your agents. They're like the traffic cops of your workflow, telling everyone who talks to whom, when they talk, and under what specific conditions. All right, let's get to the real heart of it. Microsoft gives us 5 proven plays or patterns to orchestrate our AI teams. Understanding these is absolutely key for the exam, so let's break them down. Okay, first up is concurrent orchestration. Just think of this like a big brainstorming session. You give the exact same problem to several different specialists. They all go off and work on it at the same time, in parallel, and then you get a whole bunch of diverse solutions back really, really fast. So the bottom line here is this: use this pattern for speed and to get a bunch of different perspectives, but it's totally the wrong play if one agent's work depends on another agent's results. Next up, we've got sequential orchestration. This one is your classic assembly line. Each agent does one specific step in a process, in a fixed order, building on the work of the agent that came right before it. This is absolutely perfect for those predictable, multi-stage tasks. Like drafting a document, then sending it for review, then polishing it. But you want to avoid it if you need more flexibility, or if the tasks could just be done at the same time. Pattern number 3 is group chat orchestration. This one's pretty cool. It's basically like a moderated team meeting or a debate for your AIs. It's fantastic for collaborative problem solving, where agents need to bounce ideas off each other to get to a final decision. This is the perfect setup for tasks that need review, like a maker-checker loop, where one agent creates something and another one critiques it. But honestly, it's definitely overkill if all you need is a simple, straightforward workflow. Okay, pattern 4, handoff orchestration. Think of this one exactly like a customer support escalation. We've all been there, right? A generalist agent takes the first look at a problem, figures out what's really going on, and then intelligently hands it off to a specialist who has the perfect expertise to solve it. This pattern gives you incredible flexibility, especially for problems that can change and evolve. But you gotta be careful. You have to design really clear rules for routing. Otherwise, you risk passing the problem around forever in some kind of infinite loop. And finally, we have magentic orchestration. This is the most advanced and flexible play in the entire book. Think of the magentic pattern like having a dedicated AI project manager. It's for those super complex problems where you don't even know the solution path when you start. This manager agent breaks the whole thing down, delegates tasks, and adapts the plan on the fly as the team works. So magenetic is what you reach for when you're dealing with messy, complex, open-ended problems where the answer isn't clear. It's fantastic when you need to adapt in real time and even document the whole process as you go. Okay, we has officially covered the entire playbook. Now let's lock in the key takeaways for your game plan, especially for anyone out there prepping for that AI-102 exam. Let's boil it all down. If you walk away with anything today, it should be this: understanding which pattern to use for which problem is what separates a good AI solution from a great one. This is why this stuff matters. It's all about picking the right team strategy for the job. And there you have it. The playbook is officially in your hands. You now have the strategies to turn a bunch of individual AI agents into a high-performing, problem-solving team on Azure. The only real question left is, what complex problem are you going to build a team to solve? All right, if you're gearing up for the Azure AI-102 exam, you've probably hit this wall. How do you get AI agents to actually work together? Well, today we're going to crack that problem wide open. We're breaking down the essentials of agent-to-agent communication, which is an absolutely critical skill for building powerful, real-world AI solutions. I mean, think about it. We've got these amazing AI agents, right? They can write code, they can crunch data, they can generate incredible content. But the real magic, the stuff that solves big, complex problems, that happens when they team up. And just like any human team, they need a common language, a way to communicate effectively. And that's the core challenge we're going to unpack today. So, here's how we're going to break it all down. We'll start with the why. Why do they even need to talk? Then we'll look at their digital ID cards, the brains of the operation, and how they actually get online. And stick around because we'll wrap it all up with a super handy cheat sheet for your AI-102 studies. Okay, let's dive right in. First things first, why do agents even need to talk? I mean, can't we just build one giant super agent to do everything? Well, think of it this way. It's kind of like a team of writers. You might have one AI agent that's a total rock star at writing killer headlines, and then you've got another one that's a master at creating really detailed outlines. Both are specialists, right? To get a fantastic article, you need the headline agent to pass its work over to the outline agent. If they can't talk, you just have two smart agents doing their own thing, completely isolated. And that is exactly where the solution comes in. It's called the agent-to-agent protocol, or A2A. For the exam, you just need to think of this as the official rulebook. It's the common language that lets all agents, no matter who built them, find each other, communicate, and work together on tasks. It's the foundation for everything. So why is this A2A thing such a game changer? Well, it gives us three massive advantages. First, you get real collaboration. Agents from totally different platforms can team up. Second, you get flexibility. Each agent can use the best tool for its job, its own specially tuned large language model. And third, and this is huge, security is baked right in from the start. It's not an afterthought. Okay, so if these agents need to find each other to collaborate, how do they, introduce themselves? How does one agent know what another one can actually do? Well, that brings us to the agent's digital ID card. All right, this is super, super important for the AI-102 exam, so listen up. An agent's identity has two parts. You've got the agent card, which is basically its business card. It says, hey, I'm the headline agent, you can find me at this address, and here's a quick list of all the things I'm good at. But then you have the agent skill. That's a specific service listed on the card. It's not just, I write headlines. It's, I will generate 5 SEO-optimized blog titles for you. It's the specific, actionable task. So here's the exam tip. Write this down. The agent card is for discovery, finding the right agent. The agent skill is for execution, telling that agent what to do. Discovery versus execution. Got it? Awesome. All right, so another agent has found our headline agent using its card. It wants to use that generate titles skill. So what part of the agent actually, does the work? That's where the brains of the operation come in. And that's the agent executor. Seriously, just picture it as the engine room of the agent. It's the core component that takes the standardized A2A request from the outside world and connects it to the agent's own special custom-built logic on the inside. It feels the request, gets the gears turning, and gets the response ready to go. The executor has a few really important jobs. First, it executes the task. To do that, it looks at the request context. You can think of that as the work order or the job ticket. It has all the details. Then, it communicates the results back using something called an event queue, which is just a dedicated channel for messages. And really importantly, it can also handle a cancel request. So if you need to stop a task midway, the executor takes care of it. It pretty much manages the whole life cycle of the request. So we've got the agent's ID card, and we've got its engine. But how do we actually plug this thing into the network so other agents can find it? Well, it's time to open for business. Let's walk through the entire flow, from start to finish. Step 1 is discovery. A client uses the agent card to find our agent. Step 2, the request. The client sends a job over to the A2A server. That server then routes the request to the right skill. From there, our trusty agent executor gets to work and processes it. The response gets sent back through that event queue, and finally, the client gets the result. See? It's a really clean, logical flow. Now, when a client talks to an agent, there are two main ways it can happen. A non-streaming request is like sending a quick text message. You ask a simple question, and you wait for one single complete answer back. It's great for fast interactions. But then you have streaming. A streaming request is more like watching a progress bar download a file. If the agent is working on a really long task, it can send back little updates along the way. I'm 20% done, now 50%. It's perfect for keeping the user in the loop. Phew, okay, we've covered a ton of ground. So let's bring it all home and boil it down to the absolute must-know terms for the exam. This is your A2A cheat sheet for the AI-102. All right, these are the words you need to burn into your memory. The A2A protocol, that's the common language. The agent card, that's the business card for discovery. The agent skill, that's the specific job to do. The agent executor, that's the engine that does the work. The request handler is like the air traffic controller for tasks. And of course, know the difference between non-streaming, one and done, and streaming, which gives you updates. If you know these cold, you're going to be in fantastic shape. So why do we care about all this? What's the big picture? Well, this quote from Microsoft Learn really nails it. This isn't just some abstract theory. When you understand these concepts, you can stop building little isolated AI toys and start building powerful, flexible networks of agents that can work together across different systems to solve massive, real-world problems. And that really brings us to the final, most exciting question. We figured out how to make our AI agents talk to each other. We've given them a way to team up. So the question for you is, now what? What complex, amazing problems could you solve by putting together your own specialized team of AI agents? The possibilities are, well, they're pretty much endless. Have you ever tried to get a bunch of different AI agents to cooperate on a single task? It can get complicated fast. Well, today we're going to dive into Microsoft Foundry and see how you can build really powerful, intelligent workflows that make it all seem easy. So this is really the big challenge right now. Modern AI isn't about just one big model that does everything. No, it's about getting multiple, specialized agents to work in harmony. Think about customer support, right? You might have one AI that's great at understanding the initial problem, another that's a genius at searching your knowledge base, and a third that can write a super friendly reply. If you try to hard code all those connections, it's like building a house of cards. It's just so fragile and an absolute nightmare to update. And this is exactly where Microsoft Foundry's workflows step in to save the day. It's a visual, low-code platform that lets you design and manage all these complex moving parts. So instead of getting buried in code just to handle the logic, you're literally dragging and dropping to create a visual flowchart. This is huge because it means everyone on the team, from the developers to the business folks, can actually see and understand what's going on. All right, so here's the game plan for this explainer. First, we're going to look at the absolute fundamentals, the building blocks called nodes. Then we'll get to the fun part, adding the AI-powered brains with agents. After that, we'll explore the secret sauce, the dynamic logic that ties everything together. And finally, we'll see how you take all of this and turn it into a real enterprise-ready workflow. Okay, let's start at the beginning. We need to talk about the absolute core of any workflow, nodes. These are the basic building blocks you'll be using to piece everything together. The best way to think about nodes is like they're Lego bricks. Seriously, each node is a specific action or a step in your process. Maybe it's calling an AI, making a decision, or sending a quick message. You just snap these different bricks together one by one to build out your custom automation. It's all about turning your big idea into a functional workflow, piece by piece. So let's look at the main types of bricks you get in your toolkit. You've got invoke, which is how you call up your AI agents, the brains of the whole operation. Then you have flow nodes. These are your decision makers, your if this, then that logic that routes things around. Data transformation is for all the little data jobs, like grabbing a date from a sentence. Basic chat handles the actual conversation. And end? Well, that just marks the finish line. With just these few core types, you can build some seriously sophisticated stuff. All right, so we've got our structure mapped out with nodes. Now it's time to give it some intelligence. This is where AI agents come into the picture, and they provide all the real reasoning and decision-making power for our workflow. If you think of the workflow as the conductor of an orchestra, well, the agents are the star musicians. The workflow is in charge. It sets the tempo and tells everyone when to play. But it's the agents who actually make the music. They do the heavy lifting, the thinking, classifying info, and generating responses. They're the real talent. And getting an agent into your workflow is so simple. You just grab an invoke agent node and drop it onto your canvas. Then you configure it, tell it what it knows, what tools it can use. But here's the crucial part. You have to store its output in a variable. That last step is absolutely key, because that's how the rest of the workflow gets to use the amazing insights that the agent just generated. Okay, listen up, because here's a pro tip that will save you so many headaches later on. Instead of having your agent just spit out a plain block of text, configure it to return structured data, like a JSON object. This is a total game changer for making your system reliable. Why? Because instead of trying to guess what the AI meant, you get these nice, predictable fields, like category or urgency, and you can plug those directly into your workflow's logic. It makes the whole thing way more robust and way less likely to break. So we have the structure with our nodes, and we have the brains with our agents. But what connects them? How do we make decisions based on what the agent says? That's where PowerFX comes in. It's the low-code glue that makes these workflows truly smart. This quote from the documentation just nails it. It's an Excel-like language. If you've ever written a formula in a spreadsheet, equals sum A1 to A10, you're going to feel right at home with PowerFX. It's this super accessible language that lets you add all this powerful logic and data manipulation right inside your workflow, and you don't have to be a hardcore programmer to do it. And just look at how versatile it is. You can do simple checks, like asking if an AI's confidence score is above 80% before you move forward. You can build powerful if-else logic to control the entire flow. You can even do some data crunching, like summing up a list of items or just sticking a first and last name together. This is the dynamic engine that really brings your workflow to life. Okay, we've covered the nodes, the agents, and the logic that connects them. Now let's bring it all together and see how this thing actually goes from being a drawing on a canvas to a real enterprise-grade automation. So the great thing is you don't always have to start from scratch. Foundry gives you these common patterns to start with. A sequential flow is your classic step-by-step process, perfect for simple things. Human in the loop is absolutely critical for those times you need a person to sign off on an AI's decision. And group chat is really cool. It lets you set up a whole team of specialized AI agents that can actually work together to solve really complex problems. Now, this is a really powerful feature of Foundry. Every workflow actually exists in two forms at the same time. You've got the visual canvas, which is amazing for designing, for tracing the logic, and for explaining it to people who don't code. But underneath all that is a clean YAML code representation. And for development teams, this is a massive win. It means they can use their favorite coding tools, track every change with version control like Git, and even plug these workflows into their automated deployment pipelines. Of course, building the workflow is really just the beginning. To keep it running smoothly for the long haul, you gotta follow some best practices. Regularly clean up old nodes so your design doesn't get messy. Make sure you're handling those structured outputs consistently. And please use notes to document your logic. Your future self will thank you for it. Plus, the version history is like a safety net, letting you roll back to a previous version if an update ever goes wrong. And this is where it gets really exciting. These workflows aren't just stuck on some isolated island. No, they're designed to be plugged directly into your actual applications. With the Azure AI SDK, you can take these intelligent workflows you designed visually and embed them right into your web apps, your APIs, your backend systems. You're not just building a standalone bot. You are injecting a smart, automated process into your entire software ecosystem. This quote really sums it all up, doesn't it? The goal here isn't just to automate a few simple steps. By thoughtfully combining all these pieces, the nodes, the logic, the intelligent agents, you are building something that's truly adaptive. Something that can handle the messiness of the real world. So I guess that puts the ball in your court. With these kinds of powerful visual tools available, what's the first complex business process you're thinking about transforming? The possibilities are pretty much endless. So your organization is probably adopting AI agents, right? And you've likely hit that first big wall. They're smart, for sure, but they don't know a single thing about your business. They can't access your policies, your product docs, or any of your support articles. Well, let's dive into this, because today we're going to break down how you can transform those generic agents into truly powerful knowledge-enhanced tools for your company using Microsoft Foundry IQ. Here's how we're going to tackle it. First, we'll unpack the core problem, why standard AI just doesn't cut it in the enterprise. Then we'll look at the smart solution, a technique called RAG, and the tool that makes it easy, Foundry IQ. After that, we'll get our hands dirty and see how you actually build a knowledge base and teach your agent how to use it. And finally, we'll zoom out and look at the huge strategic win you get by scaling this across your whole organization. Okay, let's get right into it. The biggest challenge with a standard AI agent is that it's basically like a brand new hire who hasn't been given access to a single company document. Sure, they're intelligent, but they're not really useful for answering specific business questions because they have zero context. And what's really important to see here is that these limitations aren't just small inconveniences. They create real business risks. That knowledge cutoff date, that means it knows nothing about your latest products. No access to your private data, that means you're only ever going to get generic, useless answers. But honestly, the worst one is that when an AI doesn't know something, it will often just make up an answer that sounds confident but is totally wrong. And that is a massive compliance and security risk you just can't afford. So how do we fix this mess? The solution is a really smart approach called Retrieval Augmented Generation, or RAG for short. And I absolutely love this subtitle. It's basically like giving your AI a library card to your company's entire universe of internal knowledge. What RAG does is it completely changes the game for how an agent gets its information. Instead of only relying on that static, pre-trained knowledge it was born with, it connects to your live, real-time knowledge sources. It's a huge shift from just remembering facts to actively retrieving them when needed. And the process itself is brilliantly simple when you break it down. First, when you ask a question, the system goes and retrieves relevant documents from your knowledge bases. Second, it augments your original question with all that juicy content it just found, giving the AI real factual context. And finally, the agent generates an answer that is grounded in your company's actual real-world data. Okay, so RAG is a fantastic theory, but let's be honest, building it from scratch is a massive engineering headache. And that brings us to the hero of our story today, Microsoft Foundry IQ. This is the tool that makes enterprise RAG not just possible, but practical and scalable. Just look at the difference here. It's night and day. On the left, you've got the DIY, build-it-yourself approach. You're configuring databases, building complex pipelines, tuning algorithms. I mean, it is a ton of work. But then you look to the right. With Foundry IQ, you're just connecting your data sources and designing the agent experience. It completely changes where you spend your time and effort. And this quote right here, it just nails the core value. Foundry IQ is a managed platform that lets you stop worrying about all the plumbing, all that complex infrastructure behind RAG, and instead focus on what truly matters. What information does your agent need, and how should it interact with your users to be as helpful as possible? So under the hood, Foundry IQ is a managed service that basically handles all the hard stuff for you. The really critical point here is that it lets you organize information by business domains. Things like HR policies or product documentation, not by some random technical location where the files happen to be stored. And because it's a shared platform, all your different agents can tap into these same knowledge bases. Okay, so how do you actually use this thing? Well, the very first step is to build a knowledge base. You do this by connecting Foundry IQ to your organization's existing data sources. This is going to be the library your agent goes to find all its answers. Let's use SharePoint as a quick example. You've got two main options here. You can connect using Remote, which queries SharePoint in real time, meaning your data is always perfectly up to date with almost no setup. Or you can choose Indexed, which pre-processes all the content for much faster, more advanced searching. It needs some updates, but it's super powerful. The choice really just depends on what you need for your project. And it's not just for SharePoint, of course. This is a super handy decision guide that shows you exactly how to pick the right data source based on where your information lives and what you're trying to do. Whether your files are sitting in Azure Blob Storage, or your data's in OneLake, or you just need to pull from the live web, there's a really clear and straightforward path to get it done. All right, so you've connected your data. Awesome. But that's really only half the job. Now we get to the most critical part of all. Actually teaching the agent how to use that knowledge so it can give you consistent, reliable, and, this is key, cited answers. Let's look at this table. Say you ask, what's our vacation policy? You could get a generic answer from the model's training data. That's just wrong. You might get the right answer, but with no source to back it up. That's totally unverifiable. What you want is that third option, an answer that is 100% correct, grounded in your data, and it explicitly cites the source document so you can trust it. So how do you get that perfect response every single time? Well, you write crystal clear, explicit instructions. This quote right here, this is the secret sauce. You have to treat these instructions like a contract with the agent. You tell it, you must always use the knowledge base. You will never answer from your training data. You will cite sources in this exact format. And here's what you do if you can't find an answer. You leave zero room for guessing. And that gives you a really simple checklist for success. A high-quality response is always grounded in your data. It always has citations. The information it gives you is actually relevant to your question, and the answer is complete. You just test your agent against these 4 points, and you keep tweaking your instructions until it gets it right every single time. Okay, now let's zoom out to the really big picture here. Because building one smart agent is cool, but the real power of Foundry IQ is in building a scalable knowledge platform that benefits your entire organization. This is the core concept right here. You build your knowledge bases one time in one central place, and then many different agents, all built for different jobs, can tap into that same single source of truth. This table is a perfect example. Your customer support agent and your developer agent can both access that product documentation knowledge base. So when you update the documentation in one place, boom, both agents instantly get smarter. At the same time, your HR assistant has exclusive access to the sensitive HR policies knowledge base. It's efficient, it's scalable, and most importantly, it guarantees consistency across the board. And that brings us to the end. We've seen how to go from a generic AI to a truly enterprise-grade agent that's grounded in your company's own reality. So the only question left is, with tools like Foundry IQ making this so much more accessible, what trapped unstructured knowledge that's hiding inside your organization will your AI unlock first?